Welcome friends, we are starting our second unit, leveling. Myself Krishnakumar. So the leveling is continued by the contouring. You remember the word contouring, we will discuss about later. Now we are going to concentrate the leveling alone, right? The slide have a picture, right? Some instrument with tripod. There is some instrument, there is a line of ray or line of sight, there is a look like a straight rod. It is the leveling stuff we are going to use. How we are going to use, we are going to discuss about it. And the background has some crisscross parallel lines, right? That is the main end product of the leveling. That is the thing deals with the contouring, right? That we will discuss later. Leveling, with respect to the science, if we define leveling as again a branch of surveying which deals with the measurement of relative heights, but in surveying definition we have seen relative position, right? So it contains all the things, but in specific leveling deals with the measurement of relative heights alone, right, of different points on, above or below. So this on, above or below, it's applicable to all the type of surveying, right? The surface of earth. Thus in leveling the measurements are taken in the vertical plane. How it was measured? See, a surveyor with tripod with the leveling instrument, and helper is holding the leveling stuff. He is seeing the reading in the leveling stuff, and the leveling stuff was holded on a peg which has a dimension of 40. So 40 plus 1260. Here for example the number is given. If you add it, you will get 1300, right? The 1300 mm or meter we will see later. And now the height of instrument can be obtained. With respect to that height of instrument, I can compute the remaining required points elevation value, right? So simple definition of leveling is process used to determine a difference in elevation between 2 points, right? What is the elevation difference between point A and point B? Whether A is higher or B is higher, or A is higher or B is higher, that can be obtained, and various points elevation value also we can obtain, right? So these are the terms and the definition you have to remember, friends. What is station here means a point where the leveling staff is kept, not the instrument position. We can keep our instrument wherever we want, but it won't be a station. The station here, the term means wherever you hold the leveling stuff, that point is called the station, right? You have to keep it in mind. Then height of instrument mean it is the elevation of plane of sight which with respect to assumed datum. The assumed datum means datum we will discuss later. From the standard reference, what is the height of my instrument, right? There is some standard point, I consider it as a standard, or temporarily I consider that point as standard, and I have a value for it. From that elevational value, what is my height of instrument, right? So it is also known as the plane of collimation, right? Next term you have to remember is datum line. The in bracket it was given with 3 letter MSL. What is MSL? It is mean sea level. In Tamil they will say kadal matta alavu, right? So is the level line which are attributed to it points level on the surface of the earth, which is the average sea level. From the sea level, what is the elevation height? Most of them you may hear the height of the Mount Everest, height of the Kanchenjunga, height of the Podigai Hills, whatever it is. They give the height with respect to the zero level of the sea. How it is considered zero level? the top surface of the sea level is considered as the zero, and it varies from country to country. For India, now we consider the Mumbai port is the zero level. So from that point, what is the height of that hill? Mount Everest or Kanchenjunga or Vindhya Hills or Podiya Hills, whatever it is, right? So that height difference. So from the datum standard reference only we are saying. So that level line is called the datum line. Then one more term we are going to use commonly for the upcoming units for a repeated number of times, that is reduced level, or in short RL, right? It is the high point from datum level. The datum line may be wherever it is, the RL of the point may be here or may be here, right? So from the datum, the RL of the point is fall, it is in rise, right? So it may happen, since our terrain is not flat, it is uneven, curved, everything. So that is the RL of the point. And benchmark, BM, this we are going to use continuously. What is benchmark? And it has many types also, we will discuss later. It is our fixed points information site and attributed placed in different places until you start raising them when conducting settlement. Without benchmark, the leveling cannot be started, or even the surveying cannot be started. Why that much important for the benchmark? I should refer something as a standard, then only I can compare with that. The definition of surveying you can remember with respect to the relative position. The relative position, you are considering the known RL of a particular point. If I know, from that only I can transfer the RL values to the other point and determine their elevation, or I can refer this elevation is the standard is what is the difference. Everything can be determined with respect to that benchmark only. Next term is backside. Back bearing, forward bearing you may hear in the compass surveying. Here also there is two terms, backside and foresight. The difference between you have to remember. Backside, BS, it is the first reading taken after placing the device. Here the device means the dumpy level or auto level in any position, so that we see the greatest possible number of points required to find the elevation. We may place an instrument at a particular position such that from that position we may cover many points to determine their elevation. But whether we can start directly, so we required a standard, we have set the benchmark. From that benchmark only I can get the remaining values. So that thing, I take the staff reading over that standard benchmark by holding the staff on it and taking the line of sight reading. That procedure is called the backside, the first reading. The backside means it is not turning back, the first reading taken from the position, new position of the device to start the survey, right? So that is the backside. So benchmark, to country, their pattern of placing the benchmark will vary, but the point fixed at a particular point will have the same elevational value. So these type of benchmarks shown in the figure are permanent benchmark. It has a standard value. It will be available within 500 kilometer once, right? So from that we can transfer to many point, and we can carry to our local area also by the process of leveling, right? From transferring those point to our local, that point become the one more benchmark such that we can have it. Then how, sir, we can do the survey without that, whether we have to travel? For that only we assume some standard points as a benchmark, which is called the temporary benchmark or arbitrary benchmark, right? So the types we will see later. Next term is foresight. I have explained. It is the last reading. I kept my instrument at one particular position. I have taken the backside, the first reading, and there are n number of points available. I have placed the leveling stuff each point. I have taken the reading. I have recorded those things, and still some more points are left out, but I am not able to see. So I need to shift my position of the instrument to somewhere else. So before shifting my instrument, I have taken the last reading. No, that reading becomes the foresight. Have you remember that? You have to remember, right? Then I shifting my instrument, that is called the change point, right? The next point is CP or turning point. Predominantly we use the change point, the point at which both backside and foresight are taken. How it is possible? See, now only I explain the foresight. It is the last reading taken from the first position of the instrument. I have now shifted. For the new position, what will be the reference point? Since from that position I may not be able to see the benchmark also, right? So the last reading taken from the first position, that becomes foresight. That value I can calculate from the standard benchmark, right? So that point becomes the reference for the new position. So I have to get back the backside in the same station. So that is the change point. So in the change point only I can take both the foresight and the backside, right? So the remaining points we are taking in the position of the same instrument position are all considered as intermediate sight, right? So the elevation of line of sight, height of instrument or HI, is the imaginary vertical level determined by the line of sight to the amount of increase or decrease for sea level, right? So this will be explained by later videos, right? So the accessories we have to use, again the tripod, plumb bob, right, is a portable 3-legged. Already we have seen in the plane table surveying the same kind of thing. It has a tripod, the adjustable tripod leg. It can be increased or it can be decreased, right? Plumb bob can be holded, and the top portion, it may be circular or it may be triangle also, right? Next is the dumpy level. It was there are various types of level. Predominantly we use the dumpy level. The later version is the automatic level. We will see later. This is the dumpy level. The bottom figure is the cross section of the dumpy level. The theory question may ask, all the parts are given 1, 2, 3 here, and their explanation are there. One is the telescope, eyepiece. This is the eyepiece. 3 is the shade to avoid the over sunlight or overshadow. This is the shade. Objective end, longitudinal bubble tube, it is at the top, and transverse bubble tube, it is in the front. Bubble tube adjusting screws, C7 is here. If it is used only for the fine adjustments, right? And diaphragm adjusting screws, here it is also permanent adjustment, we won't touch oftenly. And focusing screw, 10 is the foot screws. This 1, 2, in the cross section you are able to see only 2, but actually there will be 3, right? 3 foot screws will be there. Telescope, eyepiece, objective end, right? So these are the foot screws. Upper plane plate, tri-bag arrangement. In the foot screws and the top portion of the telescope to the bottom portion of the dumpy level is balanced by this tripod, upper plate level tri-bag arrangement. The bottom one is the foot plate where the total thing is balanced, right? Here there will be a small opening groove. Through that only I can hold my instrument over the tripod. And here one more cross section, how the telescope will be. This is the eyepiece end, I am looking any object or leveling staff, how the reading will be, the ray of the leveling staff goes to the lens, get refracted, and there will be a such a type of lens will be there, refracted, there will be a prism. From the prism, the same ray is reflected back to the again lens, and it will be seen by us, right? So there will be a line of sight, there will be a crosshair at which the reading falls, that we can see. That focusing can be done with the help of focusing screw of the telescope and the eyepiece screws also there, right? So these parts you have to remember, right, while using the instrument. How it will be when you see through the eyepiece, some helper will be holding the leveling staff. Our telescope will have crosshairs, medial, top, bottom. We required only the mid one, the mid line where it get coincide. So there are different types of leveling staff. It is in ancient time wooden leveling staff, now predominantly metal ruler, right? It is of various height, 2 meter, 3 meter, 4 meter, 5 meter of length. Usually 4 meter and 5 meter will be used. Here the standard metric leveling staff for small portion I have shown. I have explained this least count in one previous video, right? I hope you will remember. So from the bottom, the gradings are there, each alternate white, black, white, black, white, black, it goes mid one, next. So the top higher will be, here it is given 0, 1, that is 0.1 meter, 0.2 meter, 0.3, 4, 5, 6, like that, up to this is 1 meter. So each strip I have explained. The least count of the leveling staff is 0.005 meter or 5 mm or 0.5 centimeter, right? So you have to remember the minimum distance of each band, either white or black, right? It is of same size, that you have to remember, right? So how the instrument set over the tripod and how it leveled, right? Here I have shown the procedure. I will try to explain with the picture also, right? You try to read this procedure by passing it, or by seeing the picture and come back here and please read the procedure. Leveling of instrument is done to make the vertical axis of the instrument truly vertical. It is achieved by carrying out the following step. What are the steps? You read it. I try to explain with the. I hope I have shown the foot screws. These will be the position of those foot screws, right? You try to remember. It is the bottom plate I have shown in the diagram, and there will be 3 foot screws, right? 3 foot screws. There will be a bubble tube also. So consider any one as A or B or C. Better you make AB parallel to the bubble tube, right? So the step here you have to follow it. First you fully tight all the foot screws, right? All the foot screws. Then loosen all the foot screws by the single hand, either 10 or 15 rotations. All the foot screws you unloosen it, right? So then all the thing will be, I hope it will be in same level. At this time itself, sometime you get the bubble at center, may not be. If it is not, make 2 foot screws parallel to this bubble tube. You have to rotate the foot screws in both the foot screws in inner, like the arrow shown here, both the thing in inner direction, right, until the bubble get into center. If it is okay, then rotate the telescope such that the bubble tube also become perpendicular to AB, right? Now you adjust the C. either this way clockwise or anti-clockwise, right, both the way, such that you have to bring back the bubble here center. Then check again, come back to the same position whether it is in center or not. If not, lightly adjust the AB either inward or outward. Then check with the C. If in all the position the bubble is centered, then only we can say the instrument is at level and we can use for the surveying, right? So this has to be done whenever you place the instrument at new position. You have to check whenever and wherever you move. So slight adjustment of tripod itself change the leveling. So you have to check whether the bubble tube is in same level. If it varies, the staff reading taken by 1% to 0.1% will vary, right? So please remember. So you try to read this step by step. I have explained with the picture, and this is the last step, right? So here the picture shown is the auto level. Here the bubble tube will be not in the straight, it will be in circular point, right? So that is the difference, but the remaining procedure are same. Then why it is called auto level? But the adjustment level of the screw compared to dumpy level, it is very easy. Slight adjustment is enough for auto level. Both the instruments are available in our department, right? We will continue with the next topic in the next video. Thank you, friends.